In this lesson, I'll show you two examples where we solve problems involving change in enthalpy and standard enthalpies of formation. Question 1 reads, use the standard enthalpies of formation to determine delta H, which is the change in enthalpy for the reaction, and the reactions shown underneath. To do this successfully, you'll need to use the following formula, where the change in enthalpy is equal to the sum of the standard enthalpies of formation for each of the products, and our products are right here. We take their standard enthalpies of formation, we multiply it by n. N represents the number of moles of each of those compounds. And then we take the sum of the reactants, the same way we did for the products, and subtract the two. Let's go ahead and do this. We have the change in enthalpy is equal to the sum of 4 times the standard enthalpy of NO, which is 91.3, plus 6 times the standard enthalpy of H2O, which is negative 241.8. I'll put those in square brackets. And then we subtract, notice the formula, the sum of, now this time our reactants. We have 4 times NH3, its formation is negative 45.9, plus 5 times 0. And that's the case for all pure elements or diatomic elements, including O2. We can use our calculator to do this. We have 4 times 91.3 plus 6 times negative 241.8. That's the answer to the first part, minus 4 times negative 45.9, close bracket. We don't need to worry about this. It's equal to 0. And this gives us negative 902. Negative 902 kilojoules. To keep in mind significant figures, we added and multiplied at some point. So when we multiplied these two numbers, we had 3 significant figures. Here we had, or should have had, 4. Here we should have had 3. And over here, nothing. And when you add, you take into account the numbers after the decimal place. This one had 1, this one had 1, and this one had 1. So we should also have 1 in our final answer. So I'll put a decimal 0 at the end. Moving on to question number 2, we're asked, the thermite reaction in which powdered aluminum reacts with iron oxide is highly exothermic, and that reaction is shown underneath. Use the standard enthalpies of formation to find delta H for the thermite reaction. We'll be using the exact same method as before. We have delta H for the reaction is equal to the sum of the products. Al2O3, that is equal to, according to the information provided here, we have negative 1675.7 multiplied by 1 mole, plus 2 moles of iron, and iron is a pure element, therefore that is equal to 0. That takes care of the first part. I've enclosed it in square brackets. Minus, we look at this part, we have 2 aluminums. Aluminum is a pure element, so that's equal to 0. I'll just write that down. 2 times 0 is nothing. Plus Fe2O3, that's shown right here. We have 1 mole of that, negative 824.2. Using our calculator, we start with negative 1675.7 times 1 is the same thing, minus negative 824.2. This gives us negative 851.5. Negative 851.5, that is correct. To the correct number of significant figures, that's the answer to question number 2. And that is how to solve change in enthalpy and standard enthalpies of formation type problems.